You can print in metals. You can print in ceramics. You can print in alginates. You could print in food. And it turns out you can print with living cells.
3D printing in medicine is what we'll dive into in this episode of Tomorrow's Cure, a podcast from Mayo Clinic that brings the future of medicine to the present. I'm Kathy Wurzer. I'm a longtime broadcast journalist based in Minnesota, and I'm here because I have a deep interest in science, technology, and medicine. I am thrilled that our two guests have had a front row seat to how 3D printing is driving change in medicine, and they are with us today. Both are leaders at organizations that have point-of-care 3D printing, meaning they print what they need when they need it right at their facilities. Joining us right now, Dr. Jonathan Morris is the Mayo Clinic neuroradiologist who leads Mayo Clinic's 3D anatomic modeling lab. His team makes life-sized 3D models that help surgeons get a better view of what they're up against before they go into surgery, as well as surgical instruments, prosthetics, and other items. Joining us remotely is Dr. Beth Ripley. She's Deputy Chief at the VA's Office of Healthcare Innovation and Learning in Seattle. They also do 3D printing, creating everything from specialized braces to 3D models. Drs. Ripley and Morris, thanks for being with us.
Yeah, thanks for having us.
I think so many people have heard about 3D printing, but some of us may have a tough time getting our heads wrapped around what we're talking about. At its simplest, we're talking about a 3D object made from a digital file, which is built up layer by layer by a printer, right?
That's right. So what some people would understand is, if someone's carving a marble sculpture, for example, that there is this block of material and they chisel it away and eventually they come to the sculpture. So that's typically called subtractive manufacturing. If you were to make the sculpture, let's say out of another material like ceramics, you would build one slice of a time of just the material you need to eventually come up with that 3D sculpture. So two ways to bring about the same thing, but two different ways of manufacturing.
We're going to talk a lot more about this. Now, I'm curious, Dr. Ripley, at this point, what might the average person run into in terms of using 3D printing in the healthcare services?
One of the most impactful things we're doing with 3D printing in healthcare is bringing patients' imaging anatomy back into the three-dimensional space. So a patient may walk into their surgeon's office and be faced with the opportunity to hold their own heart, their own kidney, their own blood vessel in their hand, and to be able to really look at the anatomy and understand what is wrong, what needs to be fixed, how they're going to do it, and why. Being able to have something physically in front of you that you can understand while you're hearing this news, while you're making decisions about your healthcare is critically important.
So the VA system is using 3D printing in this manner. Surgeons are using it in the way you describe?
Yeah. Absolutely. So within VA, we're using 3D printing for pre-surgical planning, but we're also using it to aid patients in many interesting ways, such as in the space of assistive technologies. An assistive technology device could help you, say, grasp a pencil or grasp a makeup brush and be able to apply your own makeup again for the first time after years with a tremor or another hand disability that wouldn't let you do that. And that's one of the best and most pervasive uses of 3D printing within VA today.
You mentioned your veteran patients. Talk to us about the type of injuries that your patients come in with that make you think that 3D printing could be a solution for them.
So within the VA, obviously we're treating veterans, and there's a lot of injuries that veterans sustain over the years, particularly combat veterans. If you're jumping out of a helicopter, that's really hard on the knees and the ankles. But also, when you think about veterans, a lot of our veteran population are really adventurous, outdoorsy people too, that are doing, extreme sports or out, in the wilderness, et cetera. So we see a lot of orthopedic injuries, again, joints, ankles, knees, hands. And in that space, there's a lot we can do in the 3D printing world in order to understand the mechanics, again, we all walk differently. We're all built differently. None of us are the same. So being able to understand those mechanics are huge. And then when you think about veterans that have lost a limb, we have a lot of patients who've lost one or two legs, one or two arms. How do we replace that? And of course, we're very good in the VA with prosthetics. There's a lot we can do today, but harnessing 3D printing and thinking about some of the things you can do with the unique materials also opened the door for thinking about what are prosthetics of the future. And that's something we're actively involved in right now, is trying to understand how do we make a better leg or a better arm. And of course, all that work is being done with prosthetists who know the best on how to do this within VA. But we really do have an active interest in that space, given our unique patient population.
There's different types of 3D printing in healthcare. Some are used for traditional manufacturing of a non-custom part, where 3D printing just does something better. And then there's a whole other industry where 3D printing really shines, and that's where you're having custom geometries, custom things that you can't mill, custom ways of making a device like Beth talked about, where, you might need it for a patient who had a stroke who needs to put on eye makeup or use a certain type of spoon that's going to be very unique to their arm, their hand, their geometry. And these 3D printed models are all very unique to the patient. So every time you're making something, it's a one-off. And that's where 3D printing really shines, in that it makes custom things accessible to the masses.
Say, I want to go back to something that Dr. Ripley mentioned. And of course, we have here Dr. Ripley, and I know you have some models with you there, but Dr. Morris has gifted us with some models from his lab. Why is it important to have the ability, a surgeon now, come in to say, look, I have a patient with a tumor on their kidney, and I need to figure out how I'm going to go in and deal with this. Why is that important? Just try to explain that.
So the reason why that's important is threefold. First, when you're walking in as the patient, oftentimes you have no idea what's going on. Even if you're completely with it, you're in a moment of panic. You've just gotten bad news. You're thinking about yourself, your family, your loved ones, etc. Being able to have something physically in front of you that you can understand while you're hearing this news, while you're making decisions about your healthcare, is critically important. It really brings things back to reality in a tangible, very tangible way. So that's number one. Number two is for the surgeon, him or herself, to be able to communicate with their team about what the plan is. So oftentimes we have residents, we have trainees, we have nursing staff, ancillary staff, the imaging staff. Everybody has to be on the same page. And we're talking about really complex things. So being able to, again, ground ourselves in one truth and be able to look at the model and say, this is where we're going to cut, this is the plan, is huge. And then the third piece is sort of the gift that keeps giving, because a lot of these cases are challenging cases. And the best thing that we can do as an organization is learn from cases and share that institutional knowledge forward. So these can become teaching cases for residents and med students, the next generation, to know what happened in these cases. So that's kind of the trifecta: the patient, the care team, and then our future learners, all kind of benefiting from that one model that can really tell a story in a understandable, graspable way.
I mentioned the kidney because, Dr. Morris, you have a model that has been made in your lab of a kidney with a tumor on it. So if you give this to the doctor, the attending surgeon, as he or she is getting ready for this procedure, how does it help them?
Yeah, and I'll say a little bit about what Dr. Ripley said as well. Like, the patient experience is something that was unexpected, right? But we all know we don't have common vehicles of communication. Like, I treat spine tumors using image guidance, and I'm talking to a lay person about something really complex. And I often have to draw on a piece of paper or draw on a whiteboard or develop specific patient experience materials. And most patients don't get anything like that. They get, you have this, I'm the person who fixes that. I'm going to talk to you a lot about it, But we all know, you know that you don't understand, and I know that you don't understand. And we're trying our best to make our two worlds come together in a way that I can truly give you an informed consent about what's going to happen and talk about the risks, the benefits, and the alternatives. So in order to be able to say this is you, it's not a plastic model. This is not something you buy off the shelf and I'm talking about you to this plastic model. Like, this is your kidney, this is your blood vessels. If a picture's worth 1,000 words, then a model's worth 1,000 pictures. So I'm just going to pick up this kidney tumor model. There is a tumor, which is in green in the kidney. It's got arteries, which are blood vessels going to the tumor, veins that are draining the kidney, and then there's yellow parts where the urine is collected. So there's a lot of parts to your kidney. And not only is this helpful to the patient, but the surgeon, every kidney is unique. And I think one of the things that was really made me dedicate a large part of my career to this was we had really great surgeons at Mayo Clinic coming up and saying, this was incredibly helpful to me. And I would say, in what ways? And over our time, since we've been doing this I think about 17 years now here, the same stories kept coming back over and over. This helped me do this better because when I'm in the operative room and I have the patient open, or even worse, I don't have the patient open, I'm working through small ports, doing something minimally invasive, small cameras, limited access, which is where everything's going. The robot operates through a tiny hole. Well, this is a fairly decent size, 6-8 centimeter kidney tumor. And you're looking through a small camera through a 2 millimeter hole. When we give the surgeon a model, regardless of surgical technique, about 15% of the time, even an expert surgeon will change the way they even put someone on the table because it's easier to come from the side than come from the front. And those are things patients are unaware of, because just like when you go to your favorite car mechanic, you just trust that my car's knocking, they're going to fix it. I don't really know the details. When you're dealing with somebody's like longevity or their ability to survive, or dealing with a complex issue that is altering just not their life, their family's lives. In some cases, you're working on something really important that might affect society's lives. Those decision makings happen behind the curtain. This is something that's been sustainable across just not Mayo, just not the VA, but every major top hospital in the United States has some 3D printing capability now, because it's been proven in the medical literature, it's been proven at their local institution, and it's been proven when clinically appropriate to have better outcomes.
That's amazing. Say, Dr. Ripley, as we're seeing some of Dr. Morris's models, I understand you made your first model in 2017 in your garage using your kids' markers. Is that right?
Yes. It was a few years earlier than that we started this, but yes, many people in this field, you start to bootstrap this, new innovations, and you have to go where you can. So I had a $500 printer, and that printer was a great printer. It taught me so much. It could make a lot of models, but they were one colored. And one of the things that we've noticed, and those of you that can see the models in front of Dr. Morris, is color can be helpful. And so I went to my daughter's paintbrushes and, reached in and started painting these models to give them the color that they needed. Many of the first models that I made were single color, very low cost, post-processed by hand with acrylics, but still delivered what was really essential and important, which was the information, the anatomy, that would allow the surgeon to understand, in this case, what he needed to do.
And they were helpful, obviously.
They were. I'm happy to say I do not paint models anymore, nor are they created in the garage. We have state-of-the-art manufacturing space now, that runs under good manufacturing practices. We have multicolor, many different types of materials, but you got to start somewhere. Anytime you're innovating, you've got to start somewhere. And if you stop to wait for it to be perfect, to have all the resources, everything right, we'll never innovate. So you got to just take that leap of faith, do what you can with what you've got, and keep trying until you can get to the point where it's something hopefully a little bit more than a shoestring.
Amen.
By the way, Dr. Ripley, was there an instance when you showed a patient a model maybe some tumor, as we just talked about here, this kidney tumor. Was there a point in any of your patients where there was like an aha moment where that patient said, "Oh, yeah, I get it now"?
I think it's every single time we show a model to a patient or a surgeon, there's always
Yeah.
an aha moment. And that's one of the most amazing things about it. And in fact, that aha moment can be really fast. And when I started this as a resident, a radiology resident, we really started because we would sit in the dark room. That's where radiologists hang out, right? In the dark room, looking at thousands of images, taking those images, putting them back into the three-dimensional space in our heads so that we can write reports that describe what we see. So two-dimensional images into words. Sometimes the surgeon would come down and we tried to take them through the images. And it's really hard to take all of those two-dimensional images and put them back into three-dimensional space. So, you have like 10 surgeons around you, their team, and you'd be trying to explain things and you'd be scrolling up, scrolling down. They may come back a couple times and you're thinking, oh man, I really want to get them to understand this, but I don't think I'm there. Now, when we started printing models, and again, this is a labor of love, you'd have the model, you'd be so excited. They come down, give it to them, and they may take it, look at it 10, 20 seconds, be like, okay, got it, set it down and leave. And I'd be like, wait a second, come back. I worked really hard on this. You looked at 10 or 20 seconds, and then I realized, no, wait, that's it. That is the aha moment. In 10 or 20 seconds, they picked that up. They looked at it, they felt it, and they knew everything they needed to know. And they were ready and out. And so, that is that aha moment.
Yeah, and I often show one of the first pictures we took with 3 surgeons holding the 3D model in the OR. And I tell the audience, this picture is replicated every day, 17 years later. I first started in 1999. The same exact moment of understanding, because we spend a lifetime learning the three-dimensional world and holding objects in our hand. And actually, a large part of your brain is devoted to the sense of touch. So this is driving understanding in a way that visual understanding doesn't work. And when you come today, because of all of the advances in technology, when you come to get a CT scan, let's say of your chest and your abdomen and your pelvis, what used to be about 200 slices of images is now 13,800 images, because we can image you faster and thinner. So if you were thought of your body as a loaf of bread, every slice would be 0.6 millimeters, which is about a hair. And we're looking at 13,800 images, trying to make a life-size three-dimensional model in our head, which I doubt anyone is really good at, even those of us who think we're really good at it. But when you print it out and bring it back to the physical life, you say, well, you don't have to do any mental gymnastics. One of the things the benefits in the operative room is it really shortens the operation, because if you know what's around the corner or what's behind or what's on the other side of a tumor, and you've gone through what's called virtual surgical planning, that allows you to make cuts that you're more confident about and move at a certain pace that you're more confident about, because okay, there's no artery I'm going to hit behind there, right? There's nothing behind this wall that I can't see. I know it's there.
For patients.
Absolutely. Which, if you can reduce the time in the operative room, let's just say orthopedics, on a per 15-minute interval in the operating room, there's a known infection risk. And if you're getting your total hip done or your total knee done, or you're having a tumor removed from your leg, and you could shave 2 hours off of the surgery, well, that's a dramatic difference in your time under anesthesia, the surgeon's time in the OR, your risk of infection, and the amount of money it costs to do it, because operative rooms are incredibly expensive places to spend unnecessary time.
I'm going to switch gear for just a moment, because as I was doing some research on you both, and those who are working with you in this endeavor of 3D printing, some folks are special effects engineers. These are some pretty creative folks. I mean, Dr. Ripley, you're an art history major. Dr. Morris, you are a professional chef, which is, a pretty creative endeavor. What's the tie between medicine and having a discerning, creative eye that makes you both suited for this technology? I'll begin with Dr. Ripley.
I'm so happy you brought that up. The creative spark and the ability to see something in a new way is really important to innovation, because when you're trying to innovate, you're trying to swim upstream in a really fast moving river. Because we're just trying to get things done every day, right? Take care of patients, keep the lights on, keep moving forward. But sometimes when you want to innovate or do something new, you need to be able to step out of that stream, look around, and see where there's an opportunity, which is usually where there's a problem or confusion or something else that's not working optimally. And as Dr. Morris described, when you've gone from looking at 200 images to thousands of images and trying to like compress that back down into three-dimensional space, that's really difficult. So being somebody who's kind of artistically minded, you can start to think, I wonder if, I could create something like a sculpture, right, out of these images. And maybe it would be useful, maybe not, but maybe. And so I think that ability to see something from a different lens, step back, try it out, small, right? Start small, try it out, show it to somebody and see if you can get an aha moment is really where you need to start to move forward. I think that magic of innovation, of being able to see something from a different way, and having an organization like Mayo, like VHA, that rewards and encourages and fosters that innovative spirit is really incredible and really impactful for patients and for American healthcare.
I like the way you've said that word magic. There's something kind of magical in a sense about this.
I would say too that you develop these certain needs as you're going along. What I'm personally not great at is artistically taking that three-dimensional model and making it look even more real. So one of the groups of people I lead at Mayo Clinic is called Biomedical and Scientific Visualization. So they're a group of artists. They're medical illustrators. They have a master's degree in medical illustration. They're an amazingly talented group of people. Creative mindsets and innovation go hand in hand. But all of that wrapped up together, then you have something incredibly magical. Like people come upstairs and tour our place, and they're just like, I can't believe all this stuff happens in this place. And you're like, it is magical.
Now, how did we go from 3D printing to create models to making the leap to actual implants customized to fit the person? When did that happen, Dr. Ripley?
So
fairly recently?
that has always been, kind of in the imagination of the general public, right? If any great science fiction reader or avid science fiction reader has thought about this, but much like we had the aha moment of looking at the model, one of the aha moments about 3D printing is that there are literally thousands of different types of materials you can print in. Now, you can print in plastics or nylons that allow you to make models, but you can print in food. You can print frosting. You could print cookies. You can print in alginates. You can print in metals. You can print in ceramics. And it turns out you can print with living cells. And so a lot of the space in the biomanufacturing industry comes down to that idea that you could create either scaffolds that cells would like to grow on or print with cells themselves. And within VA, we're actually very interested in this. We have a project called VA BioBone, where we are printing with demineralized bone, actual pulverized bone particles, and a binder in order to create patient-matched, customized bone grafts that could hopefully one day replace the need to harvest a bone from your body.
I'm wondering about how clear the guidelines are that ensures that is something that is safe, or some of the devices that are being developed, are they safe and effective? How's the FDA doing with all of this?
That's a fantastic question. It's integral that we work closely with the FDA, our regulatory authorities, our safety team, et cetera, to make sure that we are making products that are not only innovative, but that are safe and effective. So within VA, we recognize that early on. We have a few different collaborations with FDA just to think about regulatory science and how do we show, to your question, that these new innovations are safe and effective? So the short answer to, is there a clear pathway for the living bone to go through a regulatory approval and be shown to be effective? Not yet, but that's exactly what we're working on right now. So every day on that project, not only are we trying to make a bone, but we're trying to ask what could go wrong and how can we mitigate the risks of what could go wrong? How do we make sure it goes right? What are the right controls that we need? What is the right safety features? What is the right experiments to demonstrate that it works? So for better or for worse, it's going to be 2 to 3 years at least before we have that bone in hand and in patients. But the good news is that we are simultaneously trying to create it, but also simultaneously trying to create what is the right regulatory and safety strategy. And then to Dr. Morris's point, what is the right distribution strategy so that we can make sure, again, that we're harnessing all the goodness we're building within the infrastructure to make sure that at the end, it's not just one site that can make this, but that this could be accessible to patients everywhere.
I don't have a lot of time left, but I have this question for you both. And because this podcast is entitled Tomorrow's Cure, so let's look at where 3D printing may go here in the future, if that's okay, it being part of tomorrow's cures. What's the next frontier for this work? I'm curious here, Dr. Ripley, what do you think?
What would be amazing is the capability for the patients to be actively involved in designing their own cures and solutions. So that might mean that they're sitting in the VA or in Mayo or whatever doctor's office they're in and explaining what they need to get better. And somebody is making it. So that's one iteration, co-designed together, made at the VA, made at Mayo, made in a hospital. But there are some things that are less risky, but really super impactful. Again, thinking in the assistive technology space. If I knew that I couldn't really grasp well with my right hand, but I really want to be able to pick up this particular item, and I have an idea on how to do that, to be able to work with my hospital about it and maybe even print it at my own home on my own 3D printer would be incredible. And so I think that's one of the things that we should be thinking about and looking forward to, because the last thing you want to do is make a patient go into the hospital if they don't have to. So I think thinking again about how we leverage the fact that this is a digital, portable technology. Can we get care, cures, services even closer to a patient, even in their home?
That's quite a future you envision. Wow.
One of the things we're focused on is the ability to go from the scan itself to a digital twin. I'll give you an example. So when we do this for spine, we take an image of the patient, which is thousands of CT scan images. If they've had metal or surgery, it might take us 2 to 3 to 4 hours to create the 3D model before we do any virtual surgical planning on it. We've built AI algorithms now to automate that process. To every spine we do at Mayo Clinic now we can have done in under 1 minute. Once we can get a digital twin of you in 3 dimensions, there's other things we can do like AI fingerprinting of what type of tumor it is. Can you not do the biopsy? Can you triage to the right chemotherapy based on the right type of tumor? Can you go right to radiation? So we do a few thousand models a year. We do 1.2 million CT scans a year. So imagine the amount of three-dimensional data there would be for making diagnostic decisions using AI on the 3D digital twin of the patient, and then creating bespoke appliances when needed, right? To be able to do that through generative design, through AI design, to where you get a scan, and before you're even out, change back into your clothes, we have a 3D digital twin of you. If we need to print it, we could. If it needs to go to augmented reality and be projected over you in the OR, it could. It can be transferred to your phone in your portal, and when you log in, you can have an AI medical digital expert discussing your three-dimensional model with you, and you can move it around with your own finger. Just the AI digital twin part is a massive effort. To be able to do that on like 1.2 million scans and be able to get the data to the people when they need it at the right time, including the medical device design, that's a huge challenge. But that's something that we really see as, okay, if this is going to have a greater impact on a greater number of patients, just not at Mayo Clinic, but everywhere, then these tools are going to have to be created and leveraged to the greater society.
Truly personalized medicine.
Absolutely.
Yeah. This has been absolutely fascinating. Both of you have been just terrific. I appreciate your time. Thank you for what you're doing, too.
Thanks for having us.
Yeah, thank you. Thank you for coming and interviewing us.
Subscribe to Tomorrow's Cure wherever you get your podcasts for future conversations.